Raj Gokul.
Yeah, actually, I just joined to.
Do you find this in WRC 297 only sustained loads is applicable? Why it is so in PVElite? Did you find anything?
WRC 297 sustained load is applicable. Why? Because it is a cylindrical connection.
Whether it's mentioned anywhere in the code means only sustain to be taken.
In WRC 297 it is mentioned. No, where if there is a cylinder and if there is an opening on the cylinder, then your sustained load will take.
Okay, so it's already mentioned in the code and that one, right?
Yeah, in 297 it is. I think not 297 or 537. Somewhere it is mentioned.
Okay.
This is this question I raised by our what to call the ASME auditing.
Okay. So actually, Siddharth also raised a query to PVElite, but they didn't come up with a good answer with that one. So it's there.
No, actually, this kind of questions. No, this is PVElite. They are not going in depth of WRC. Just they are deriving like with respect to the what are the formulas it is given in the code.
Okay.
And those step by step also PVElite will not give. They will PVElite simply will give the end results.
Yeah. That's
how many iteration it is taking and what is the final value, whether it is passing or failing.
That's why it's difficult as to understand why they are suddenly taking this.
So only thing is we need to do a manual calculation. Manual calculation bit easy, I think.
So you prepared any Excel or anything for this one? For
no, but I can check with my friends because few of my friends they did some R&D in 107 and 297. So let me check.
Okay, actually Siddharth also started putting values in Excel and they are splitting the what are the loads in that one in thermal.
So but sure. Yeah, but few of my friends did, and yeah, I'll get. I will try to catch up with them, and I'll get what I as much I can.
Okay, Siddharth, if they get, they will share with you.
Okay. Sure, definitely. Okay. They are doing manual like equivalent validation, no?
Manual validation we are doing,
but most of the cases we see most of the cases and major scenarios we are performing manual calculations, right? Like nozzle reinforcement, nozzle limitation, shell thickness, dish thickness. I think mostly all the parts what we are performing in the PVElite we are doing manual calculation.
Manual means in Excel we are doing, right?
Yeah, in Excel, yeah.
Okay, so we are validating.
Even conical transition also we are validating.
Okay. So you are getting almost same the result which giving the.
Not almost, but it will give some 1 or 2% difference will be there. Yeah, that is mainly we observe due to this decimals.
Okay.
If any specific point, if you guys like facing some huge difference, let me know. I will also cross check.
Okay.
Because in Dubai PVElite team, I'm in touch with like in PVElite Shiva Ganesh is there, Natarajan is there, Vinod or Pandian, Vinod Pandian is there. So some of the technical team I'm in touch. So if you guys any facing any difficulty, let me know. I'll talk to them.
Siddharth, you are specifying some particular name, no?
Yeah, that was an old gentleman actually, Ray De La Force.
Yeah, he is from Image Graphics. Sorry,
yeah, but he used to come to India, to deliver the lectures about the PVElite, and he was the technical expert. I think.
Technical expert and very difficult to reach him. He will not respond also.
So you are in.
But only you. There is one guy called Faisal. You can talk to Faisal and Faisal can help you out.
Yeah. Do you have?
Faisal is there. So he is technically staffed fellow.
Yeah.
I'll share his contact in the group.
Okay. If you okay, Siddharth, you can check.
Faisal.
Yeah.
You can contact him. He will give you all the support. Whenever I am stucking anywhere in PVElite, he will support.
Yeah, he is from marketing actually. His technical support team is.
Now he shifted to technical, not in marketing.
Okay.
So, yeah, Siddharth, you have Faisal number also with you?
Yes, yes.
Okay.
Yeah, you can contact him. Now, previously, last 2 years before, he was there in marketing. Now, I think he is in technical team.
Oh,
Uh, okay. Any issue, Gokul, you want to discuss? Yeah.
No, just I want to know about what are the discussions going on.
Okay. There are few, I think, Ramakrishna.
Because I have seen some photos, so it was very difficult. It looks like something different. So that's why I thought, okay, that was a discussion going on. So let me join like that.
Normally at the skirts bottom, how many supports you used to put maximum?
tailing beam. Tailing beam.
Tailing wheel?
Yeah.
Two I'll put.
It's in parallel or it's in cross? How you used to put?
Cross.
Okay.
Like a hutch.
Yeah, that's
Okay. So,
that's-
but
Yeah, like a
H,
hutch.
but H type is not given in Dennis Moss, no?
Yeah. Yeah, no. Actually, you need to consider number of structure as 4.
Okay.
Okay, see, even though if it is welded, so you need to consider number of structure as 4. See, why we are deciding tailing, why we are putting tailing beam? To avoid deflection in the PCD during erection or lifting. So after erection, they will cut the tailing beam and they will trash it. If it is not mandatory to keep.
Correct. Yeah.
So what they will do? What is the main thing to calculate the tailing beam is radius of gyration of the beam, moment of inertia of the beam, and length of the beam, and quantity of the beam. So these are the 4 factors which is more than enough to calculate the cross beam stress.
Yeah. No. Not. It is not.
I'll share I will share the calculation. Most probably by Monday I'll share because today is weekend, no. So what we derived and we are using in our regular job.
Okay. So you are not referring to Dennis Moss?
No. See, Dennis Moss Dennis Moss we are using for one structure. So accordingly, we are offsetting. We are doing some offset and we are performing.
Yeah. So you mean
with respect to the center point, we are offsetting and we are performing.
Like 2 point you mean?
Yeah, 2 point.
Yeah, but again, this validation and that one, whether it will be approved, means how to we convince where we referred and how it will be.
No, we are actually we in tailing like calculation, we are submitting along with the tailing beam and we are submitting.
Mm-hmm. But whether that is accept means you vary means you varied from this Dennis Moss and that one. No? You are not referring exact. You are not referring the Dennis Moss.
We are tailing. We have taken the concept of Dennis Moss and we modified with respect to our requirement.
Okay, so that is acceptable, right?
Yeah. We have used and we succeed also.
Okay, Ramakrishna, I think it's better.
Recently, we delivered, even for European standard also, we use the same properties.
Mm-hmm. Okay.
Recently, we delivered. Today, 4 equipment delivered today. It went out from dispatch from our shop.
Okay, then you share on Monday, Ramakrishna. I think you can use that one.
Monday I'll share.
I have one more question.
Yeah.
And there is no there is no complication in the beam. It is a normal, very basic calculation. But what is the thing is you need to offset the distance.
Mm-hmm.
Oh, okay.
If even though if you are not offsetting also, one straight beam calculation is enough and increase the quantity.
Okay.
Mm-hmm.
Yeah, because your governing point is a major length. Major length will be your center point.
Okay.
But you are not putting in the center point.
Okay.
Your beam length is reduced when your offsettings are for 500 or 600 mm.
Okay.
Yeah, then there will not be any big difference.
Okay.
And obviously you are checking with your allowable and actual stresses.
Yes.
You are comparing and you are taking a rigidity value also.
Yeah.
So it will pass.
Okay.
It's passing.
Oh.
and we are success. We are doing in our actual jobs.
So have you done this configuration with the two tailing lugs also?
Yes. It is applicable only for two tailing leg. One tailing leg, normal pipe, straight pipe is enough.
No. Well, I have
Instead of
two tailing lugs. Okay.
Yeah, he's
Yes,
saying that
you can do.
Yeah,
For two tailing legs only, I'm talking about.
Yeah, two tailing lugs and one central beam and perpendicular to that one more cross beam.
See, for two tailing leg, one central beam is not required. For where the tailing leg center point is there, you need to fix the beam in that.
Oh, okay. Then we need to provide.
Okay, so two beam is required.
Yes.
And it is like a hutch type.
Okay.
See, from top view, if you see means like from the bottom view, if you see means it will be a hutch type.
Okay. One second. Let me share my screen. Actually, I will share what is the present condition. So once again, actually it was done by somebody else, and I am doing the correction that. Okay.
Yeah, no.
Actually, that guy now our trainians are here, so lifting lugs are here. Tailing lugs are here. So he provided one beam here and perpendicular to that one more beam he has given. So I think whether this is correct. I think this is not correct, no?
No, this is not correct. See, this is in some point your PCD may what to call it.
So okay, so it has to be like this.
H type he is telling. H type you have to go.
Right?
Inside one more.
Inside one more. Okay.
H type. Okay.
Okay. Just for further strengthening.
Yeah.
Okay. Understood. Okay. I think this calculation is available in Dennis Moss.
Brother, not in the center. Actually, the long green line you drawn, no?
Yeah.
Like the same in 0 to 180 you have to draw.
Yeah. Okay, I understood. Yeah, this.
Now to 90 to 270 you have drawn two lines. Like the same you need to draw for 0 to 180 also.
You mean acha? Like this also? I mean one more.
Exactly. Yeah, fully.
Okay.
Exactly.
Oh.
So two beams will be full beam and two beams will be partial beam. You cut and weld.
Yeah. That's okay. So you mean like this?
Exactly.
And this is not required.
Which is not. Yeah, that is not required.
So this is not a H type. It is I think it's a plus.
Double cross or
double
whatever
cross.
thing else.
Yeah.
Plus. Yeah, we can say double plus.
Okay. Acha, so this much arrangement is required. Okay.
Yeah, see, if you use we have worked out in many ways, okay, and we found that UPC or UNC 152 cross 152 cross 30. That beam is that beam is satisfying up to 280 metric ton weight.
Okay.
If your vessel weight is up to 200, lifting weight is 280 ton or 290 ton, your UNC or UC properly, I don't know. 152 cross 152 cross 30, it is withstanding.
Okay.
He is I think only in 60 tons. It's not.
You can blindly close your eyes. You can decide the material and you can proceed.
Yeah. Because actually my weight is only hardly 70 ton.
For 60 ton, one is enough.
No, somehow that local it is failing. Maybe that okay.
His diameter is 3.5 meters, dude. Diameter is too high, 14 mm thick. I think so. Carbon steel he mentioned, SA36.
Yeah, okay. My vessel is, you mean skirt is SA36?
Yes.
And diameter
Actually,
also
in
is
fact, it is 36 highest 2062.
No, actually, if you say 36 inch, your yield is 240 or 250, I think, right? 250.
Yeah, correct.
So,
Yeah.
Your cross-sectional properties of your skirt and skirt is coming less than 250.
Yeah, I need to check up actually. It is showing some failure. Maybe that Excel sheet. I'm using
See,
previous
in my less than 90 ton or 95 less than 100 ton, let us say, two tailing leg is also not required, unless otherwise if you are not performing WRC for the tailing leg. If you are performing WRC for the tailing leg, definitely there will be a requirement of pad or there will be a requirement of insert plate in the tailing leg.
Okay.
See, in our case, or else you need to increase the tailing leg thickness of maximum 50 or 60, something like that.
Yeah.
Instead of putting a pad.
What they have done is they want to use the less thickness, 25 mm thick tailing lug only. So that's why they put
No problem. If it is not fabricated, put them a square insert plate.
Correct. Yeah.
Square sectional insert plate.
Okay.
While performing calculation, consider as a diameter. What is the OD? Consider in our vessel. Now what we are doing is 280 metric ton. Vessel is lifting in full rest of the condition.
Okay.
It's almost 40 meter column.
Okay.
But what is the thing is your skirt base ring is governing by combined loading, where there is and it is subjected why, because is blast load is more.
Oh, okay.
Yeah, and my base ring thickness is 90 mm.
Okay.
Yeah. So my tailing leg, we didn't provide any insert plate for that, because your skirt thickness in the bottom portion, it is almost 40 mm.
Okay.
Okay.
So we have avoided.
Okay, I think you share that one, your Excel. So
Sure.
Monday
That Excel will be very, very user friendly. Okay. It's like that Excel we prepared, especially I prepared like a local author where we are learning in the engineering days, right?
Mm-hmm.
Okay.
Yeah, local author book we will use to study, compared to standard author books.
Okay.
So that Excel file will be like a local author book referring, you will understand very easily.
Okay.
Okay, Ramakrishna, you want to ask some other? So one more.
Yeah. I have one more. I have filter vessel and the body flanges are standard flanges.
Mm-hmm.
So
body flanges?
Standard flanges.
Body flanges are standard size. So
okay. Something like 24 inch or 18 inch like that.
Not even 24 inch. It is just 12 inch only.
Mm-hmm.
Okay.
Small ones. Okay.
The question is for the blind flange. So it is the corrosion allowance is 3 mm.
Mm-hmm.
So
yeah, definitely.
Okay.
So then in that case, our RF is generally only 2 mm. So we need to perform the calculation as per UC 34, correct?
Exactly. Or else there will be a major NC in the audit.
Correct. Okay.
Previously, in before 6-7 years, they are not finding this error. But in last 6-7 years, in all the companies where the ASME audit is happening, everywhere they are finding this and they are getting that.
Okay.
Yeah, usually for the blind flanges, even though if it is not a filter and if there is any connection process nozzle where there is a loading is there, we will consider corrosion allowance 3 mm.
Okay.
Yeah, sometimes manway also we'll use to check.
Mm-hmm.
Okay.
Yeah. Very rare cases.
So, but manways we are not. Generally we are not checking.
Yeah, we are not doing. But in rare case, some client, for we recently around 1 or 2 years before we did that people they asked to check for the manways also.
Maybe some loads coming or maybe some equipment.
Yes, I don't know. Like we try to convince them in all the aspects.
Mm-hmm.
Even we shared our response from our authorized inspector also, but they specifically wanted that, and they we don't have any other option to proceed, perform.
Mm-hmm. Okay, Ramakrishna, I think we need to consider the corrosion allowance and we have to perform that.
Yeah, mandatorily we have to consider.
Perform that.
Yeah.
Okay, Ramakrishna.
Yeah.
Okay, Ramakrishna, you got your answer.
Yeah.
Okay. Any more?
When the blast load in PVElite, we have an option to give it as a wind pressure.
Mm-hmm.
Yeah, exactly.
And in some projects, where specifically client mentioned that you apply as an external pressure instead of like a wind load. Yeah.
Both the cases
So where it is
acceptable. Both the cases is acceptable.
Yeah.
But what is the thing is, if you are considering as a wind pressure, no, your blast load will consider like what to call after the vessel area also it will cover.
Yeah, I mean
Until the deflection limit it will cover.
Okay.
If you consider in the wind case, no, it will consider
Yeah.
up to the deflection level. Whereas if you consider in the external pressure, it will limit up to the thickness. It will not go beyond the thickness.
Correct. Yeah.
I mean, let us say OD. Let us say outside diameter of the vessel. It will not go after outside diameter of the vessel.
So both the cases you are telling it will be okay. It's not issue.
Yeah, but preferable is the wind.
Okay. So Ramakrishna, I think wind. If you try, then maybe the.
One is why some clients specify that you apply like a wind, and why some clients specify apply it like pressure.
See,
external
yeah.
pressure.
What is the thing is
both I want to understand
where the client is given there is the external pressure, no. Your blast load will be higher than the expected one.
Oh, okay.
But the blast load which is given by the client, no, like that value will be the highest value than the operating value. I forgot. Kirti.
Achha, you mean they will take a more safety margin?
They will more safety margin. Exactly. Something like 20-30% higher than the actual.
Okay. Thank you, sir.
Hello. Yeah. Kumar.
Yeah, hi.
Hi. Good evening.
I joined a bit late. Nobody's there or what?
Yeah, they left recently, just now.
You closed it?
Yeah, almost. We're close.
Okay. I joined a little late actually. Just let me introduce myself. My name is Indra Kumar. I'm working as a design and proposal manager. So I've been in this industry from last 15 years.
Okay. You 8 o'clock our meeting time is there, so you came, I think.
I understood that. I thought might be like, recently you just posted something about spiral heat exchanger.
Yeah. In discussion there is going on.
Manufacturing of spiral heat exchangers since we last 2.5 years we started manufacturing spiral, and we are doing good into that. So I thought the topic will be interesting, and I seen your message too late actually.
Actually, the spiral questions has started in our meeting, and they got some answers, but that's not satisfactory. I think in next week when you come, maybe we'll discuss further in that one, spiral heat exchanger.
Okay.
So Mr. Kumar, you are from shell and tube heat exchangers, process design, thermal design you do?
Yeah, I do thermal design.
So how do you evaluate mean metal temperatures for conditions which are apart from the normal operation? Subset condition, just like a shell site startup, tube site startup condition, or any pressure drop, sudden pressure drop likewise?
Yeah, so see, first we need to understand how you are going to operate this heat exchanger. Let's say you are having some steam heater or any process equipment or shell and tube heat exchanger. So you know what will be the startup conditions and what will be the shutdown conditions. So normally what we do, we consider no shell in fluid condition first and no tube in condition and no fluid in tube conditions. Based on that, whatever the fluid temperature is expected to come in heat exchanger, that will be your tube temperature. Suppose let's say there is a condition where steam is entering into the shell and there is no fluid inside the tube. So the first condition for mean metal, so in that case, let's say we are having steam in the shell, so we know the temperature of steam. The steam temperature will be the mean metal temperature of your shell, and the tube temperature will be equals to your shell, your steam temperature. So in that case, mean metal temperature of tube and shell will be same, and that will be considered for mechanical design. The second case, we will have no fluid in the shell that the shell temperature will be the environment temperature. So if you are operating in India, it will be taken at 30 degrees Celsius. And the tube side, which is whatever the highest temperature you will get in the process, that will be considered at mean metal temperature of steam of the tube. So this is the tube two conditions normally taken into considerations. Sometimes, suppose in the case of steam, normally it is advisable, to operate equipment so that there is no fluid in the, steam should not enter in heat exchangers unless and until your process fluid flowing through the tubes. But if there is some condition other than startup and shutdown condition, and if you are expecting some sudden surge in the temperature of one of the fluid, then that is to be taken into consideration. So that sudden surge in the temperature, if it is during process, you are having the process is going on and you want to, you are expecting that there might a chances of high temperature fluid that may come in heat exchangers. So that for that particular process, exchanger is to be simulated, and after simulating exchanger for particular change in the duty, we have to calculate the mean metal temperature. So that particular simulation you can either do in any heat transfer equipment design software like STRI or STFS.
We'll continue in the next section.
Yeah,
actually, it will be little
Yeah,
longer
we'll discuss in the next session.
Okay.
subsequent sessions.
Okay,
Yes,
thank you.
okay,
Sorry
thank
for
you,
the
Dr.
late joining. We'll discuss in the next session.
Okay. Yeah. Next.
Thank you.
Okay.
Thank you, Siddharth.
Thank you. Bye. Good night.
Yeah, thank you, Kumar.